viewers, everyone. Today we are going to learn about another interesting topic from the thermodynamics, mechanical energy and formulas related to mechanical energy. I have discussed with you in the last class. Today we are going to learn about law. What are the laws of thermodynamics? Let us understand laws of thermodynamics. Laws of thermodynamics. Let us take the first law. I'm taking the first law. Let us discuss in detail about the first law of thermodynamics. What are the silent features and the main instructions given by first law of thermodynamics? It is also called law of conservation of energy. How energy is going to be conserved, conservation of energy, how it is happening. It will be learned in the topic called law of conservation. First law. According to first law of thermodynamics, if you take the energy in a process may be transformed. The energy, whatever it is there, the energy in a process may be transformed from one form to another, right? You know that, but is neither created nor destroyed. That is very important statement. Total energy of the system and surrounding is constant. If you take second silent feature, total energy that is going to be constant and it is present in the surroundings and conserved. The loss gained in the energy of a system must be exactly compensated by gain or loss. The loss or gain in the energy of a system must be compensated or satisfied by gain or loss of energy through the surrounding environment. It should be gained or it should be lost with respect to surrounding environment. Okay, this is the first law of thermodynamics. First law rules generally rules out the existence of a perpetual motion or machine of the first kind. So perpetual motion, it is generally rules out the existence of a rule out, completely it rules out existence of a perpetual motion machine. It is a machine which operates in a cycles, it can produce work without consuming energy. So where you can see perpetual pedal motion energy, it is commonly produced which operates in cycles or bicycles. In the cycles, it can produce the work done without consuming energy. Whatever work is done here, it is done without consuming any kind of energy, hence it is very useful. So, in equation according to the chemistry, delta U equal to Q plus W work done, or this is the main formula for first law of thermodynamics, or delta H equal to, right, delta U minus P delta V is the mathematical sum of first law of thermodynamics. You may get a direct question. The question says, what is the mathematical expansion for first law of thermodynamics? Now we have to know the limitations. What are the exact limitations of a first law of thermodynamics? First law of thermodynamics does not indicate spontaneous nature of process. So whatever spontaneous nature process, it does not satisfied or indicated by first law of thermodynamics. So the point is, first law does not or cannot. It is an indication. It can't be an indication of the spontaneous nature of process, any process. If it doesn't not indicate whether or not a process occurs in a specific direction. So as you know that it doesn't indicate how the energy process going to happen, right? In a specific direction, in a specific direction, right? Without involving any external energy or without involving any external force or any external work or agency. Here, agency can be taken as a work or any kind of support from external environment. It doesn't indicate what fraction of one form of energy is converted. It doesn't completely indicates. It is definitely not indicating, right? What fraction of one form of energy, how much, what fraction in the sense, how much amount of or fraction of energy it is generally, right, is converted into another form. Simply saying that, as you know very well, it also said in the beginning, one form of energy is converted into another form, but what fraction of energy is converted can't be explained by the first law of thermodynamics, right? One more, you have to learn here internal energy. If you take any kind of system, it has internal energy indicated by U, right? The sum of form of all energies, both kinetic potential energies, except the gravitational energy of the particles in a system or in a system is called internal energy. So we say that there may be a potential energy, the sum of potential energy, the sum of kinetic energy, right? And also etc. together called as a internal energy. What is the exception for this? Except which does not include gravitational energy. Why? Because gravitational energy is naturally occurring now. So gravitational energy is going to happen by the specific Earth or planets like Earth and the Moon. And internal energy U. Energy stored in a substance at a constant temperature and a volume is called internal energy. So, in simple words, how to define internal energy? Energy that is stored, completely available or residued in a substance at a constant temperature. Energy in the form of an temperature, right? Which is generally known as or said as the internal energy. And the total volume of this energy, here we can say that the internal energy. Internal energy depends on the nature of substance. Internal energy is going to be depends upon the nature of substance. It is completely depends upon the substance, any kind of substance. It is impossible to know the exact intrinsic energy of a system. We can't identify exact exact intrinsic form of energy, cannot be defined or cannot be uh, taken in a system, but the changes in intrinsic energy can be determined. So whatever changes happen in intrinsic energy, it can be defined and it is indicated by delta U, right? First law of thermodynamics, you know very well. And as you know, first law of thermodynamics, according to that, it says internal energy formula U2 minus U1 equal to delta U, that is equal to Q plus W, right? It is a state function and an extensive property in a cyclic process. If you take in a specific cyclic process, delta U is equal to 0, right? Next, after that, what we mean by enthalpy? Let us take enthalpy. What do you mean by enthalpy? If you take enthalpy is indicated by capital H. Enthalpy or heat content is defined as the sum of the internal energy and the work form of energy. So it is nothing but sum of sum of internal energy, sum of internal energy, not only sum of internal energy and the work form of energy, the work form of energy is together called as the enthalpy. Enthalpy rate PV, you can define it. Capital H is equal to U plus PV, right? The total heat content of a system at a constant pressure. Total, the total heat content of a the total heat content of a system at constant pressure and temperature is known as enthalpy. Is that called enthalpy? Once again, I am defining, right? The total heat, and its a content of a system at a constant pressure is known as enthalpy. The most stable state of a substance at 1 atmospheric pressure and 25 degrees centigrade is called the standard state. So, what is the most stable state of substance? Most stable state of substance, right? Along with that, at a 1 atmospheric pressure on the mercury scale and temperature must be 25 degrees, right? It is known as a standard state of a matter or a system. This standard state, which is very useful for production of energy. The enthalpies of all elements in their standard state are taken as zero. If you take all the elements in the periodic table, all the elements and their enthalpies, enthalpies in their nature, it is taken in the standard form, it is generally equal to 0. Now, example, let us take some of the example. Element stable form. All the elements are, you know very well. Um, they are stable form, stable in nature. Carbon, as you know, it is available in the form of graphite, right? So the graphite nature cannot be changed, isn't it? Sulfur available in the rhombic state. If you take the sulfur, it is going to be available in the rhombic state. Okay, and phosphorus, it is going to be available in a white color form. Okay, along with that, the amount of heat evolved or absorbed when the chemical reaction takes place between the reactants as indicated in the stoichiometric equation is called heat or enthalpy of a reaction. How to define enthalpy of a reaction in a reactor? Let us take a chemical reactor. A reaction is being happening. Now in this case, amount of heat evolved or amount of heat produced, amount of heat evolved, the amount of heat evolved or absorbed when the chemical reaction, when the chemical reaction, when the chemical reaction takes place between the reactants, takes place between the reactants and the reactants as indicated according to the standards of a stoichiometric, stoichiometric equation and the standards of stoichiometric equations, right? Stoichiometric equation is called as heat or enthalpy of a reaction. The heat of a reaction delta H depends upon the heat of a reaction. If you carefully see the reheat of a reaction, which is going to be delta H depends on, it is going to depend upon different properties. Very, very important this one. Direct question can be given in the NEET exam. The physical state of a reactant and products. So the first dependency of a heat reaction on delta H, physical and reactants, physical properties of a reactants. B, it is also directly proportional to a reaction is conducted at a constant pressure or constant volume. So constant pressure, constant volume is also required for the reaction. Temperature is also one of the important factor for this reaction. And stoichiometry of equation. What is stoichiometry of equation? We will discuss in the chapter stoichiometry. Okay, we just remember this stoichiometry equation, stoichiometry of a equation. Okay, heat of a reaction at a constant heat of a reaction at a constant volume. Let us take heat of a reaction, heat of a reaction at a constant volume is equal to the change in, it is equal to change in the intrinsic energy indicated by delta U. Next, heat of a reaction at constant pressure equal to the change in internal energy and external work. Heat of a reaction, if you take the heat of a particular reaction I am taking, right? It is constant, right? Heat of a reaction at constant pressure, at a constant pressure. I'm talking about P here. P nothing but pressure is equal to, that is equal to change in internal energy and external work also. External work also. Change in, if you take the change in enthalpy delta H is equivalent to, if you take the delta H is equivalent to delta U plus P delta V. Okay, where if you take the terms given here, delta H is equal to the formula written already, right? Now here, if you take delta N is equal to, right? Total number of moles of the gases. N refers to total. N refers to number of moles of a gas or gaseous products minus total number of moles, moles of gases reactants, right? Now, whereas delta H is equal to enthalpy change. I already told you delta H is equal to enthalpy change. Enthalpy change is indicated by delta H. And delta H enthalpy change or heat of reaction at a constant pressure. Delta U is equal to heat change. I'm talking about heat change here only, not enthalpy change, right? Heat change or heat of reaction at a constant volume, or heat of a reaction at a constant volume. Okay, this is what I would like to tell to you. Now, apart from that, in case of solids and liquids, let us take some of the solids, some of the liquids. In case of solids as well as liquids, if it takes solids and liquids, right, participating in a reaction, delta H is equal to delta U and P delta V is equal to 0. If delta N is a positive, then delta H is less than, right? So let us take, if delta N is a positive term, then delta H, if you carefully see, it is greater than delta U. Whereas you know that if delta N is negative, then what will happen? Delta H is less than equal to delta U. If delta N is 0, let us take the third term also. If delta N is 0, then delta H is equal to delta N. Okay. So delta H is equal to delta U. Sorry, this one. Delta U we have to mention. Delta U. Okay. So the reaction in which heat is evolved are called exothermic reaction. If heat is evolved, then it is called exothermic reaction, right? If heat is consumed, if the heat is consumed or absorbed, if heat is absorbed, then it is called endothermic reaction. Absorbed downward and released upward. Got my point? Now for exothermic reaction, let us take for exothermic reaction HR greater than equal to HP or UR greater than equal to UP, and for endothermic reactions, HP pressure greater than equal to HR or UP is less than or equal to UR. Okay. Here one small correction I am doing you. In the exothermic reaction, HR is greater than equal to HP or UR greater than equal to UP, and HP is greater than equal to HR or UP is greater than equal to UR. Okay, these terms are very, very important for examination point of view. In the next video, I'll give you one more important session. Thank you.